In this video, I'll be going over how to solve a variety of different types of equations. So I'll be looking at equations that have rational exponents, radical equations, absolute value equations, and equations that are quadratic in form. So let's begin with equations that have rational exponents. First, let's recall that if we have something like this, the cube root of 8, we can write that as 8 to the 1/3 power. And when we write 8 with an exponent that's a fraction, or a rational exponent, the denominator is the root, and the numerator is the exponent. So a second example of this is if we have, let's say, the 4th root of x to the 3rd. We could rewrite this as x to the 3/4. So 3 is the exponent, 4 is the root. So keeping this in mind, let's try and solve some equations that have these rational exponents. So suppose we have x to the 5/4 equal to 32. So what we want to do is we want to undo this rational exponent. And to do that, we multiply, or rather, we raise both sides to the reciprocal of that exponent. So if we raise both sides to the 4/5, these exponents, we're going to multiply the numerator and the denominator together. We're going to get x to the 20th over 20, which is just x to the 1st power. And when we raise 32 to the 4/5, we can write it as 32 to the 4/5, and then we just need to evaluate 32 to the 4/5. And what this means is x is equal to 32. We have the 5th root of 32, and we're going to raise that to the 4th power. So we can evaluate either the exponent, so the 4, 32 to the 4, we can do that part first, or we can take the 5th root of 32 first. Having a hard time right now. We can take the 5th root first and then raise it to the 4th. So both of these are equivalent. Now I think it's easier to do the second one first. So let's do this one first, where we take the 5th root of 32 and then we raise it to the 4th power. Well, the 5th root of 32 is equal to 2. So what we end up with is x is equal to 2 to the 4th power, which is 16. Okay, so the solution to this equation is x is equal to 16. And we can check this by simply saying x to the 5/4, is that equal to 32? Well, the 4th root of 16 is 2. 2 to the 5th is equal to 32. So this does, in fact, check. Let's look at one more example. Y to the 3/2 is equal to 125. We raise both sides to the reciprocal of the fraction exponent. So this cancels. We get y is equal to 125 to the 2/3, which we can write as 3rd root of 125 raised to the 2nd power. The 3rd root of 125 is 5, so we end up with 5 squared, which is 25, and that's our solution. Next, let's look at radical equations. Now, a radical equation is an equation that has a radical, oftentimes a square root symbol, where the variable is part of the radicand. So in other words, the variable is underneath the radical symbol. So typically what we do is we're going to square both sides of the equation to undo the square root. In each of these examples that I've listed, all of these are the square roots. However, suppose this was the 3rd root. Well, what we'd do is we would cube both sides in that instance. So depending on what the index of the radical is, the index is just saying what the root is, depending on what the index is, that tells us what exponent we're going to use to remove that radical. So let's look at a couple examples of this. How about square root of 15 minus 2x is equal to x? Let's see what we end up with here. So I'm going to square both sides. Squaring on the left cancels the radical, so we end up with 15 minus 2x is equal to x squared. Because we have x squared, this is a quadratic equation. To solve a quadratic equation, we're going to set this equal to 0. Add 2x to both sides, subtract 15. This quadratic equation can be factored. X plus 5, x minus 3. So we end up with x being equal to negative 5, or x being equal to 3. Now, it's really important, in fact, it's necessary to check a solution whenever we square both sides of an equation, or cube both sides, etc. Now, what's really happening when we square both sides, on the right-hand side over here, we're multiplying x by another x. So what we've done is we've introduced another x into this equation. And when we do that, oftentimes one of these x's will not actually check. And we call those extraneous solutions. They're just extra solutions that don't actually work to solve the equation. So let's check both of these. If we have x is equal to negative 5, we get square root 15 minus 2, negative 5. Is that equal to negative 5? Well, I already know that this isn't going to be true because the left side, when I take the square root, is not going to equal a negative number. But just to prove that, 15, negative 2 times negative 5 is positive 10. I get the square root of 25. We want the principal root, so we want the positive. So that does not work. So negative 5 does not check here. And then let's test x is equal to 3. We get 15 minus 2 times 3. Running out of room. Is that equal to 3? Well, we have square root of 15 minus 6. Is that equal to 3? And it is. So that works. So only x equal to 3 is our solution. Let's look at this example. Square root of x plus 3 is equal to 3x minus 1. So again, we're going to square both sides. That removes the radical on the left-hand side. On the right-hand side, when we square this, we need to expand this binomial multiplication. So 3x times 3x, we get 9x squared. When we simplify, this is what we end up with. So again, this is a quadratic equation. I'm going to set this equal to 0. So we end up with 9x squared minus 7x minus 2. And this, I believe, factors. Let's see, 9x and x. We would say like this, 9x plus 2, x minus 1. Is that right? Okay, that looks good to me. So we'll set each of those equal to 0 and solve. So we get x is equal to negative 2/9. Here we get x is equal to 1. So let's check this. First off, let's do the fraction. We get square root of negative 2/9 plus 3. Is that equal to 3 times negative 2/9 minus 1? This is kind of messy. 3 is the same thing as 27/9. So we get 25/9. Square root of 25/9 is 5 over 3. So let's see if that's equal to the right side. We get negative 6/9 minus 1, which is 9/9. We get negative 15/9, which is negative 5/3. So that is not equal. So that means that x is equal to negative 2/9 is not a solution. For the other value, you get x is equal to 1. We get 1 plus 3. Is that equal to 3 times 1 minus 1? Square root of 4 is 2. 3 times 1 is 3 minus 1 is 2. And that does check. So x is equal to 1 is our solution here. Next up, let's look at absolute value equations. Absolute value equations are simply equations where the variable is inside of an absolute value symbol. So if we remember an absolute value, let's say we have absolute value, let's say absolute value of x is equal to 5. Well, x could be equal to positive 5 here, but x could also be equal to negative 5. Because if we take the absolute value of negative 5, we also get positive 5. So in other words, this value could be positive or negative. We set x equal to positive or negative of that value there. So to solve this equation, we're going to say 2x minus 6 is equal to positive 8. 2x minus 6 is equal to negative 8. And then we just solve each of these linear equations separately. So we get x is equal to 7. And then we get x is equal to negative 1. And those are the two solutions. Okay, so solving absolute value equations, not a big deal. We just need to remember this step where we branch off into two equations, one where we have the absolute value expression equal to a positive value, and one where it's a negative value. So a couple things to remember. If we have 3x plus 4 inside absolute value, and that's equal to negative 9, well, an absolute value expression can never be equal to a negative number. So for an equation like this, where an absolute value is equal to a negative, we say no solution, okay, because an absolute value expression can never be equal to a negative. And if we have an absolute value expression that's equal to 0, well, it doesn't make sense to branch this into two different equations where we would have plus 0 and minus 0. We're just going to remove the absolute value symbol and solve this. So negative 5x plus 10, when is that equal to 0? It's when x is equal to 2. So there's only one solution here, and that's going to be x equal to 2. All right, so those are a couple special cases. So keeping those in mind as we solve these types of problems. Well, let's solve one more absolute value equation here. Okay, so before I branch this one off into two separate strands, I want to isolate the absolute value expression first. Okay, so 3x minus 5 in the absolute value symbol is equal to 10. And then we're going to branch this into two equations, one where it's equal to negative 10 and one where it's positive 10. So we get 3x is equal to 15, x is equal to 5, and then 3x is equal to negative 5, x is equal to negative 5/3. So those are our two solutions. Finally, let's look at some equations that are quadratic in form. So an example of this would be x to the 4th minus 17x squared plus 16 is equal to 0. So recall that a quadratic equation is in this form. Okay, now the equation that I just wrote, x to the 4th, etc., is not strictly a quadratic equation. However, an equation is quadratic in form when the leading or the degree is double the exponent on the b term. So 4 and 2, 4 is double the 2 here, so we can rewrite this, or we would say that this is quadratic in form. And so we can rewrite it in this form and then use all the strategies we know for solving quadratic equations. So what we're going to do is we're going to say, let's let x to the 4th be equal to y squared. Actually, I'm going to go the other way. So instead, let's this exponent, or this variable, we're going to say let x squared be equal to y. And then if we square both of these, we're going to end up with x to the 4th equal to y squared. So what we have is a substitution we can make for x squared and for x to the fourth. So for x to the fourth, we're going to say y squared minus 17. For x squared, we're going to say y. Okay, so we have rewritten this to be a quadratic equation. And this is a quadratic equation that we can factor. Y minus 16, y minus 1. So we get y is equal to 16, y is equal to 1. But ultimately, we don't want to solve for y, we want to solve for x, because that's what our original equation was. So remember, we set up here y is equal to x squared. So we're going to replace that y with x squared. So x is going to be equal to plus or minus 4. And then x squared is equal to 1, so x is equal to plus or minus 1. So we get 4 solutions here. And that makes sense because our original equation was 4th degree. Alright, and then for our last equation, we have x plus 2 getting squared plus 11 times x plus 2 minus 12. Now we could multiply all of this out and simplify, and then we would see that this is a quadratic equation. However, I'm going to make a substitution. I'm going to say x plus 2, let's let that be equal to y. So x plus 2 right here is equal to y, so we're going to say y squared plus 11y minus 12 is equal to 0. And this is going to factor y, let's see, y minus 1, y plus 12. Okay, so y is going to be equal to 1 here, and negative 12. But again, we don't want to solve for y, we want to solve for x. So let's resubstitute in y is equal to x plus 2. So x is going to be equal to negative 1. X plus 2 is equal to negative 12, so x is equal to negative 14. Those are our 2 solutions. And again, we could always check our work when we have an equation to see if we're getting the right answer.